The amount of radon-222, a radioactive isotope of radon, decreases according to the law of exponential decay. Wait a minute. So far we've dealt with exponential growth, but what about exponential decay? Well, it's still proportional. And so the only difference is, well, the initial value, which has nothing to do with its proportionality, but the K value is going to determine that it is decay rather than growth. That's really it. That's all it's going to be. So let's proceed. 5 kilograms of 222 radon, that's what that really is, that's just the symbol for it, was dumped along the edge of the road by a disgruntled employee of a nuclear plant. Okay, so far we know that we have the same formula, and I'm going to call it Y for radon. Call it R if you want to. I don't feel like using R though. I'm going to go with Y. And we know we have this. And we also know that they dumped 5 kilograms along the edge of the road, and we know that they're mad about something, and they work at a nuclear plant. So, you know, if you're mad and you work at a nuclear plant, you have access to these things, something's really wrong. I hope things work out well at the end of this math problem. So 5 kilograms was dumped along the edge of the road. Well, when it was dumped along the edge of the road, it was dumped along the edge of the road. Let me rephrase that. When this employee threw it out, how much time had elapsed? 0. So I could say that when time equals 0, the amount of radon was 5. And then how long will it take for there to be 1 kilogram remaining? That's the question. I like to put it way over here. So how long will it take? That's a question of time for there to be 1 kilogram of radon remaining. And then it says radon-222 has a half-life of 3.82 days. I almost said 38.2 days. Wow, decimals. I'll get you every time. So let's just kind of jump in with what we know and find what we don't know. And I never wrote that down anywhere, but we'll deal with it. So actually, when they tell us this, they're telling us the C value. So if you want to see it worked out, again, you could say K times 0. Instead of OK, I'll put K times 0. So C equals 5. They're really just telling us that was the initial amount, which I knew that. So then they're going to say, okay, how long will it take for there to be 1 kilogram remaining? Here's the thing. We know C now, but we don't know K, and we do have to find time when Y equals 1. So we need to find K. So this is really what I'm aiming for. So K, what's K? I don't know. How are we going to find it? I don't know. But here's what I do know. It takes 3.82 days to have half of what you had to start with. So because I started with 5, I'm just going to say that Y equals 5. Whoops, whoops, whoops. No, it doesn't. Y doesn't equal 5. Because I started with 5, so C equals 5. Y equals half of that. And so we're going to just go with that. We're going to continue to just plug these numbers in. So half of 5 is 2.5. You don't have to use 5 and 2.5. You could use any number and half of it. You could say 20 and 10. It doesn't matter. I'm just going to go with the numbers that they gave me. So 2.5 equals 5 e to the 3.82 k, and we're going to find out what k is by dividing by 5, and that's going to give me a half, which was the point anyway. You could have just started there. E to the 3.82 k, and we're going to do the natural logarithm of this thing. So log of 1/2 equals 3.82 k, and k is 1 over 3.82 natural log of 1/2. Yay! I know what k is now. Good for me. Fantastic. Why don't we plug this in and find out what k is from a decimal point of view? So 1 over 3.82 natural log of 1/2. This is k. You can write it if you want to. Notice that up until now, k has been positive. Now k is negative. I just want to point that out because this one is, well, decay, not growth. Good to know. So negative 0.181 is my k, but I will use that entire thing as I proceed. I did store it in my calculator. So let's keep going. T equals what? Don't know. Y equals 1. C equals 5 because this whole thing just started when somebody dumped 5 kilograms out. E to the k, we'll just use k times t, and we'll solve it. So 1/5 equals e to the kt. So natural log of 1/5 equals kt, and so 1 over k, natural log of 1/5 equals t, and we'll go from there. 1 over k, natural log of 1/5. fifth, which is 0.2, of course. And it takes 3, whoops, something about that feels very wrong. Something feels very wrong about that. Make sure I'm right. Make sure I don't need, nope. 3.852 days. Something about that really does feel a little fishy, and I'm gonna tell you why. So I'm second guessing. Oh, I used log, not natural log. Whoa, my goodness, that's tragic. So 1 over k. Let me tell you what was really going through my mind right there. Once I finished typing this, that's better, much better. Okay. It's good to kind of look at your answer and see if it makes sense, and I think this was a good learning opportunity. There are no mistakes, only happy accidents. So 8.870 actually. 8.870 days is how long it takes. So my original answer, I think, was this, and I got 3.852. That is super close to this. So these are about the same, and I knew something was wrong because if it takes 3.82 days to reach half of what it was, which in this case was 2.5, then it would take an additional 0.03 days to decay all the way down to 1. Something was wrong. Something was wrong. So I had to kind of look back through my work. So using the log was wrong. Using natural log was right. I knew that. Just pressed the wrong button. Last problem. The population of ferrets at a ferret preserve, I made that up, it's not a thing, in South Dakota, I made that up, that's not really a state either, increases according to the law of exponential growth. So you could start with dp dt equals kp and go through the whole process, but the population is ce to the kt. And if the population doubles every 6.5 years, what is the constant of variation? Wait a minute, I didn't even have to go here with this necessarily. I could have just, let me see, let me try to reword this. The population doubles every 6.5 years. You know what, I didn't need to do that. I was about to say, no, I can do it from here. What I'm gonna do is just basically double the population. If I started with 1 ferret and I ended up with 2, then what's k? So they're asking for k right here. That's what they're really asking for. And again, I was mistaken when I said, you didn't have to go all the way this far. You could have done this. I was thinking of a different type of problem altogether. My apologies. So 6.5 in k, and we'll just solve it the way we've been doing the other one. So the natural log of 2 equals 6.5k. You eventually get the hang of these to the point where you could say, oh, natural log of this divided by that. So 1 over 6.5 natural log of 2, and we'll find out what it is. I have no idea. Hopefully I'll type the right thing this time. Natural log of 2. And the constant of variation in this case is applicable here and applicable up at the top with the differential equation, 0.107.